In the 18.1 video, we described the data model for the Syndeia Cloud graph. In this video, we will show how we can combine this knowledge with the Gremlin graph query language to efficiently extract the information we need from the graph. Syndeia users who want to ask anything but the simplest questions will need to learn something about Gremlin, and there are good learning resources available. In a nutshell, Gremlin queries, starting from a vertex or an edge, traverse the graph looking for the desired connection pattern. As we traverse each vertex or edge, we test it to see whether it matches the pattern. Complexity in writing Gremlin queries for Syndeia Cloud arises from several factors. Syndeia Cloud can store information from multiple systems, organized as Syndeia projects. In many cases, we will be seeking information from a specific project and want to filter out everything else. Syndeia Cloud includes information from many different models created in different tools and repositories. We typically want to identify specific model elements and model element types. Syndeia integrates many version-managed repositories, and Syndeia Cloud retains older versions of relations and artifacts. We often want to confine our query results to elements valid at a particular point in time, usually the latest version of the model. One way to approach the problem is to learn how to filter each vertex and edge as we traverse the graph. Then we can string these steps together to build more complex queries. We will look at some very simple examples to show how Gremlin applies these filters. Our first example asks for all relationships, or edges, meeting two conditions. They are part of a specific Syndeia project, DZSB01, and they include only the latest version of the relationships. We can break down the Gremlin query. We start by asking for edges. We set one conditional, that the edge has a property named container with a value of DZSB01, which is the Syndeia project where my system of interest is. We set a second conditional, that the edge has a property is latest with the value true. That is, it is the latest version of that relationship that has been uploaded to Syndeia Cloud. If we drop this second conditional, the result is similar, except that an earlier version of the relationship between the JAMA and SysML requirements is shown. It is shown with a dashed outline for the edge and the vertex APU. In this scenario, a user has edited and saved an earlier version of the JAMA APU requirement in JAMA, then updated the Syndeia connection from the SysML APU requirement. The graph retains both the old and new versions for both the JAMA artifact and the Syndeia connection. A similar pattern can be used for intramodel relations. In Syndeia version 3.3, this applies to only the relations inside of SysML models, which can be pushed to the Syndeia Cloud by the Syndeia SysML plugins. The next example asks for all relationships or edges meeting two conditions. They are part of a specific SysML model, CONT4, and they include only relations of type abstraction. The SysML model connections are stored in a container named CONT4, and the name of the relation is abstraction. Alternatively, we could filter by the relation type, REL type 45. At the end of this video, we will discuss how to find out the names of containers and the types of relations. Our first two examples showed how to filter edge steps. We can also filter artifacts, but need to modify our approach. In this example, we want all artifacts of type TestRailCase in a TestRail project named Unmanned Aerial Vehicle. The first line asks for vertices in the category of artifact. The second is a conditional, which looks for an outgoing edge has type, terminating in an artifact type vertex named TestRailCase. This relationship would look like this, but the where function in Gremlin isn't asking to traverse this path, just to choose starting vertices where it applies. Alternately, we could apply a conditional on the vertex property type ArtType8, which corresponds to TestRailCase. The third line is a conditional on the container. Unlike relations, container is not a property of artifacts, so we need to look for an outgoing edge owned by, terminating in vertex named Unmanned Aerial Vehicle, the container name corresponding to a specific TestRail project. We can make the query about artifacts even more specific. Here we are looking for artifacts of type item in a TeamCenter repository named TeamCenter 11.2 at Intercax. The first line checks for a hasType edge to a vertex named item, similar to the last example. However, the name item might not be unique. There might be other TeamCenter repositories in use that have items, or even items in other kinds of repositories. In the next two lines, we take the chain one step further to the specific repository vertex to avoid that possibility. Filtering artifacts by the Syndea project they are used in represents another challenge. Artifacts don't belong to Syndea projects. Only intermodel connections that link artifacts in different repositories do. To find artifacts that take part in such connections, we look for either outgoing or incoming relationships. This is why we use the both step on edges, to the TeamCenter artifacts that are owned by Syndea project DZSB01. They would look like this, a SysML block connected to a TeamCenter item. This doesn't preclude the possibility that the same artifacts would be used in other Syndea projects. It is quite reasonable that the same PLM item might be used in many different systems and system models. Using the owned by and hasType edges to filter artifacts and relations implies that we know the containers, repositories, and types available in the graph. The Query Builder can be helpful in identifying these. If we ask Query Builder to show all the repositories, we get an array. We can right-click any of them and view name, skey, and type. The skey value can be used instead of the name in filtering by repository, with the advantage of being shorter and unique. We can do the same thing with artifact types. Remember that the artifact type skey and type properties, ArtType 12 here, are assigned by Syndea in the order in which they are created in the graph, and may be different for each instance of Syndea Cloud. It may help to generate a table of names and keys as a reference for your particular Syndea repository. In the Query Builder results for artifact type, we can choose the table format and use the Download button in the upper corner to generate a CSV file. In Excel, it might look like this. We will demonstrate more features for the Query Builder in the next video. Syndea is evolving rapidly. User feedback, particularly in enterprise-scale production environments, is driving that evolution. Contact us to discuss your requirements.